All right, welcome back. So we are going backwards now to the notes that we skipped the other day. We're going to go back and do adjacent and vertical angles, and hopefully they make a little bit more sense, some of the characteristics that they have now that we've talked about complementary and supplementary. But you have the definitions for these written down already. I hope you should have these written down in your vocabulary list. But adjacent angles, the first thing that I want you to know about adjacent angles, all that means is that they're two angles that share a vertex and a side. So adjacent angles mean that they share a vertex and a side, which sounds a little bit complicated, but all that looks like, all that means is that they're next to each other and their vertexes are the same. So, for example, an adjacent angle would just look something like this. Here's one of the angles, and an angle adjacent to it would have the same vertex, and it would just share this side in between them. So they can look all kinds of different ways. You can have adjacent angles that are really big and open. You can have adjacent angles that are skinnier. All it means is that they share a vertex that's the same and a side. So this angle has this vertex and this side. This angle has this vertex and this side as well. So they are adjacent. Adjacent means next to each other. Vertical angles are opposite angles when something very specific happens. They're opposite angles when two lines intersect. They're opposite angles when two lines intersect. So what that looks like for you, and I'll draw a couple of them over here. So this is adjacent, this is adjacent. Vertical angles, they're opposite angles when two lines intersect. So if I have a line right here, and I have a line that intersects it, meaning it crosses it, they cross right here. And what's cool about vertical angles, they're opposite each other. So this angle right here, we'll call this angle A, and we'll call this B, and this one C, and this one D. Angle A and angle C are opposite each other. See, they're not adjacent. A and D are adjacent because they're next to each other. A and C are opposite each other. So these are vertical angles. And what's really cool about vertical angles is they add up, or excuse me, they don't add up, they equal the same thing. They're congruent. They're equal to each other. Whatever angle A is, angle C is the same thing. And I'll show you just really quick why that's true. Angle A and angle D, those two angles together, if I add them, A plus D equals 180 because A and D make a straight line right here. Now C and D, if I turn my paper like this, C and D, if I add them together, they also make a straight line. So C plus D equals 180. So A and D equals 180, C and D equals 180, which means that A and C have to be the same thing because they both added to D equal 180. So opposite angles are adjacent. So vertical angles, they're formed by intersecting lines, and they're the opposite angles from each other. All right? So one of the things that you need to learn how to do this week is to draw vertical angles. So we're going to draw these angles, which is really easy to do, theoretically. You just have to draw one line and intersect it. But there's some things that we want you to do specifically. This example says to draw a pair of vertical angles that measure 40 degrees. So you can draw two intersecting lines, but we want you to do so in a way that makes sure that there's an angle that's 40 degrees. So the first step to do that is to use a protractor to draw the given angle. So you're going to use a protractor to draw the given angle. And the easiest way to do that is I'm going to make my vertex, and I'm going to draw one of my sides right here. That's one of the sides, and now I want to use my protractor to make this a 40-degree angle. So remember, to draw this angle, I need to center my protractor on my vertex, and I need to line that line up with 0. So here's my vertex, here's my line, it's on the 0, and now I want to go up and measure 40 degrees. Now remember, I want to start at 0. I don't want to start on the outside at 180 and go all the way to 40. I want to start at 0, 10, 20, 30, 40. So that's going to put me right here. Okay, so my spot is right there, kind of in the middle of my notes a little bit. And we don't have to draw all the way to that point, but I'm going to draw this angle. So I connect my vertex to that point that I just drew. I connect my vertex with my straight edge. But I'm not going to go all the way to that point. There's no reason to do that. So what I've done right here is I've made a 40-degree angle. So that's step 1. Draw the given angle, 40 degrees. Step 2 is to use a straight edge to extend the sides to form 2 intersecting lines. 2 intersecting lines. So that all that means is right here's where these intersect. I want to make those lines keep going so that it looks like my picture right up here. So I'm going to line my straight edge up on this line, and I'm going to make it longer. I'm going to extend it this way. And then I'm going to do the same with this line here. I'm going to line up my straight edge, and I'm going to extend it this way. So now I have 2 intersecting lines, and this one's 40 degrees right here. This angle, which means that this angle is 40 degrees because they're opposite each other. And if you can do a little bit of quick math, if this is 40 degrees and it makes a straight line, it means that these 2 angles are supplementary, so they add up to 180. If this one's if this one's 40, then this one has to be 140 degrees. Which is cool because if that one's 140 degrees, it's opposite of this one, so this one is also 140 degrees. So we found those 4 angles pretty quick. And we did what they wanted. We drew a pair of vertical angles that measures 40 degrees. That's one thing that you need to be able to do today. The other thing, which is kind of like what we did the other day with our complementary and supplementary angles, is to find the missing angle. So in this piece right here, we know that this is 80 degrees, and it's vertical with this one, so we know that this one's also 80 degrees. But we don't know what this piece is. We know that these 2 add up to equal something, but we don't know what that x is. We don't know what that missing piece is. So to find the measure of each angle, we know what this angle is, but we want to figure out what the x is. So step 1 is to decide if the angles are either vertical or adjacent. Okay. So if these angles right here, this angle and this one, 80 degrees and this one, those angles are not vertical, they're not across from each other, they're adjacent. So decide if the angles are vertical or adjacent. That's step 1. These ones down here, this angle and this angle are across from each other, which makes them vertical angles, which means they're the same. These 2 are adjacent and they make a straight line. So step 2, if the angles are adjacent, set up an equation equal to what they add up to. So we're going to set up an equation equal to 180 degrees, because these 2 add up to 180 degrees because they're next to each other and they make a straight line, and solve for the x. Okay. Now if the angles are vertical, we're going to set them equal to each other, because 3x and 2x plus 50, those are the same things. So we're going to set them equal to each other and solve for the x. All right, so step 2 for this one, these 2, we've got 80 degrees and 4x minus 40. So 80 plus 4x minus 140 equals, those 2 added together equal 180. Okay. Now this one, 3x and 2x plus 50, those don't add together because they're vertical. We're going to set them equal to each other. So 3x equals 2x plus 50. All right, so this one here, 80 plus 4x minus 140 equals 180. Before we can do railroad tracks, we need the 80 and the minus 140 to go together. So 80 minus 140, if I subtract 140, becomes negative 60 plus 4x equals 180. Now I can do my railroad tracks. I circle what's connected to my x, which is a plus 4. Well, a plus 4 is being multiplied to my x, so I have to get rid of this minus 60. So I have to plus 60 to both sides. So 4x equals 180 plus 60 is 240. Now to get rid of 4 times x, I divide by 4. I divide by 4. X is equal to 240 divided by 4. 24 divided by 4 is 6, but I have a 0, so it's actually x is going to be equal to 60. Okay? So to check that, I'm going to plug it in. If x is equal to 60, 4 times 60 is 240, minus 140 is 100, which means that that angle's 100. And if this angle's 80 and this angle's 100, that makes sense. That's correct. That's what I wanted to get. Okay, so I know that that's the correct answer. This one here, 3x equals 2x plus 50. What I want to do first, and I don't know how much some of you have done this, is we need to get our x's together. We don't want x's over here and over here. So to get my x's on the same side, right here, this does say 2x, but it's a positive 2x. And if I want to get rid of the positive 2x from this side, I need to subtract 2x's away, which means I have to subtract 2x's from this side. So if I have 2x's and I take 2x's away, they're gone, and all I'm left with is 50. And if I have 3x's and I take away 2x's, all I'm left with is 1x. So I think that x is equal to 50. So let's plug that back in and see what we get. 3 times x is 3 times 50, so that becomes 150. 2 times x is 2 times 50, which is 100, plus 50, that also becomes 150. So I'm pretty sure that my answer is correct because I got the same things. Step 3 down here just says that if you're looking for the measure of each angle, there's a couple of ways that we can do that if you weren't able to do it using complementary and supplementary. But you plug in your number for the x. So you plug in your value that you found for the x and solve. So I plugged, like on this one, I thought x was 60, so I plugged it in and I solved and found out that this is equal to 100. For this one, I took my 50, I plugged it in, 3 times x, 3 times 50 is 150, and I solved. Okay, so that's adjacent and vertical angles. You use them, again, finding that they're adjacent or vertical, that's 6th grade math. This year, you use the fact that they're adjacent or vertical. You use that fact to make an equation to help us solve for missing pieces. So in your homework, you're going to have, it looks like this, 7.2, adjacent and vertical angles. The first 3 problems, the first 7 problems, you're going to not just tell whether they're adjacent or vertical, but you also need to find the missing piece. So these 2 angles are next to each other, so they're adjacent, and knowing what you know about them, this angle and this angle, if we add them together, they're equal to something. These 2 angles are opposite each other, so they're vertical angles, which means they're the same thing. So we can set those equal to each other and solve for x. Use that information to solve these first 7 problems. 8, kind of the same idea. If you remember some things from yesterday, you won't need to worry about whether they're adjacent or not. You can just use yesterday's math to do that one. The second part of this, it's going to have you actually draw. So it wants you to draw a pair of vertical angles like we did on the notes, and then it wants you to find the measurements of these 3 angles that are missing right here, angles 1, 2, and 3. All right, so good luck to you. If you have any problems, come see me at the table.